Let's get right to it. Pumps are everywhere, but the real unsung hero is the seal. Most people obsess over impellers and flow rates, but ignore seals at their peril. The seal is what keeps high-pressure fluids from turning your equipment and your workplace into a disaster zone. A spinning shaft needs a gap, but that gap is a leak waiting to happen. Modern mechanical seals changed the game, quietly preventing leaks and saving industries from costly downtime and hazards. A failed seal can mean lost product, environmental fines, and safety risks. By the end of this, you'll know what a mechanical seal is, why it matters, and how to choose the right one. We'll break down how they work, why they're better than old-school methods, and what types you'll find in the field. No jargon, just the essentials. Grab your safety glasses. Let's dive into the component that keeps industry running leak-free. Let's get started. So, what exactly is a mechanical seal? It's a device that stops fluid from leaking out where a pump's spinning shaft enters the casing. The secret: two ultra-flat rings, one stationary, one spinning, pressed together by a spring. Between them, a microscopic film of fluid lubricates and seals, preventing wear and leaks. The spring keeps the faces in contact, even with vibration or misalignment. Think of it like two polished ice cubes gliding with a thin film of water, smooth, controlled, and nearly frictionless. The faces are made from super hard materials like silicon carbide or tungsten carbide, built to last. Secondary seals, O-rings or bellows, handle static sealing and flexibility. Together, these parts form a robust system that keeps fluid where it belongs. It's a marvel of engineering, all about balance and precision. That's the heart of a mechanical seal. Simple, but brilliant. Before mechanical seals, pumps used gland packing, basically stuffing rope around the shaft and squeezing it tight. It worked, but only by allowing leaks to lubricate and cool the packing. That meant wasted product, constant mess, and frequent maintenance. Mechanical seals changed everything. They use a micro-thin fluid film, not brute force, so friction and energy loss are minimal. Properly installed, they have virtually zero visible leakage, crucial for hazardous or valuable fluids. Packing needs constant adjustment. Seals are fit and forget, running for years with little attention. Less downtime, less risk, and a safer workplace. For dangerous chemicals or pollutants, a leak-free seal isn't just better, it's essential. Mechanical seals are the clear winner for efficiency, safety, and reliability. They're the modern standard for a reason. Ditch the packing, embrace the seal. Your equipment and your team will thank you. Not all seals are created equal. First, balanced versus unbalanced. Unbalanced seals are simple but struggle at high pressures, risking dry running and failure. Balanced seals use clever geometry to reduce face pressure, keeping the fluid film stable even under stress, essential for high-pressure jobs. Next, single versus double seals. Single seals are common for non-hazardous fluids, but for toxic, abrasive, or hazardous fluids, double seals are the gold standard. Double seals use a pressurized barrier fluid between two sets of faces, ensuring that if the inner seal fails, only clean fluid escapes, not the dangerous stuff. This setup is mandatory in industries where leaks are unacceptable. The right seal type depends on your pressure, fluid, and safety needs. Choose wisely, your process and people depend on it. Balanced, double seals, ultimate safety. Single, unbalanced, simple jobs. Match the seal to the challenge. The secret to a long-lasting seal: materials. For water, carbon graphite against ceramic or stainless steel is common, cost-effective, and reliable. For abrasive or corrosive fluids, you need hard faces, silicon carbide or tungsten carbide. These materials resist wear and chemical attack, lasting far longer in tough conditions. Elastomers, O-rings, and bellows must match the fluid and temperature. Nitrile and Viton are standard, but aggressive chemicals need high-end options like FFKM. Metal parts, springs, sleeves, are usually stainless steel, but harsh environments may require exotic alloys like Hastelloy or titanium. The wrong material anywhere can mean rapid failure. Every part must be compatible with your fluid and conditions. Material selection is a puzzle. Get every piece right. That's how you build a seal that lasts. Don't cut corners. The right materials make all the difference. Let's see seals in action. In municipal water plants, single unbalanced seals with carbon graphite and ceramic faces handle clean water reliably and affordably. In chemical plants, double seals with silicon carbide faces and FFKM elastomers, plus corrosion-resistant metals, keep hazardous acids safely contained. Food processing, thick abrasive fluids like tomato paste need robust, non-clogging cartridge seals with hard faces and FDA-compliant materials. Each application demands a tailored seal. Wrong choice means failure. A water seal won't survive in acid. An acid seal is overkill for water. Know your process, fluid, and risks. The right seal keeps things running safely and smoothly. Real-world success is all about matching the seal to the job. One size never fits all. Choose smart, and your equipment will thank you. Faced with a pump, how do you pick the right seal? Start with the stamps method. Size, temperature, application, media, pressure, speed. Gather all the data: shaft size, fluid type, temperature range, pressure, speed, and what the pump is actually doing. Use this info to choose seal type and materials. For high pressure, go balanced. For hazardous fluids, double seals are a must. Check chemical compatibility for every material. Don't guess. Hard faces for abrasives, soft faces for clean fluids. Never cut corners on safety. Double seals cost less than a cleanup or accident. For water and non-hazardous fluids, single seals are fine. Follow the checklist, and seal selection becomes simple and safe. The right process leads to the right seal. Make your choice count. Here's what matters. Mechanical seals are a leap forward in reliability, safety, and efficiency. They save energy, prevent leaks, and reduce maintenance. But there's no universal seal. Success depends on matching the seal to your application. Investigate pressure, temperature, speed, and fluid details. Use that data to pick the right type and materials. Even the best seal fails if installed wrong. Precision and cleanliness are critical. Follow instructions, align the pump, and keep everything spotless. A few careful steps at installation save days of downtime. Mastering seals means mastering reliability and safety. Details matter. Get them right, and your system will run trouble-free. Keep learning, keep improving, and you'll build systems that last. Stay tuned for our next guide, where we'll show you how to install a seal step by step.